Hi students, I am Praveen Sebastian Paul. In this lecture, we are discussing the construction of a bipolar junction transistor. The construction and circuit symbol for both NPN and PNP transistors are given in this figure, with the arrow in the circuit symbol always showing the direction of conventional current flow between the base terminal and its emitter terminal. The direction of the arrow always points from positive P region to the negative N region. For both type of transistor, this labeling is used exactly the same as for the standard diode symbol. The transistors are usually to amplify or switch the electronic signals, and they are mainly two types of transistors. They are junction transistors and point contact transistors. The junction transistors are often used because of their small size and easy to construct mechanism. The junction transistors are again classified into two. They are PNP and NPN type. Both NPN and PNP transistors have three terminals like emitter, base and collector terminal. And the transistors can be constructed by using one of the five basic techniques. Based upon these techniques, they are classified as ground junction transistor, alloy junction transistor, diffusion junction transistor, epitaxial junction transistor, and point contact junction transistor. And now we are going to discuss about these five methods. First, we are discussing the ground junction transistor. The ground junction transistor was developed by 1948 by William Shockley. It was developed 6 months after the first bipolar junction transistor was made. And the NPN ground junction transistor is made up of a single crystal of a semiconductor material. That material may be either silicon or germanium. The impurity concentration of this semiconductor material is changed during the crystal drawing operation by adding N-type or P-type atoms as required. The second one is the alloy junction transistor. The alloy transistor or alloy junction transistor is a germanium bipolar junction transistor which was developed at General Electric in 1951 as an improvement over the earlier ground junction transistor. The alloy junction technique is also called a fused technique. The alloy junction transistor is made up of a thin wafer of N-type germanium material forming the base with two dots of indium attached to opposite side of the N-type material. The whole structure is raised to a higher temperature above the melting point of indium but below that of germanium. A tiny portion of the indium dissolves and enter into the wafer of N-type material. Thus, the P-type material is created at two sides of the N-type wafer. The upper P-type material is the emitter and the lower P-type material is the collector, and the center thin N-type material is the base. The collector is made larger than the emitter to withstand the heavy current. So now we are moving towards the diffusion junction transistor. The diffusion junction transistor was developed by Bell Laboratories in 1954. The diffusion junction transistor is a transistor which is formed when the N-type silicon wafer called substrate is exposed to P-type and N-type gaseous impurities. The diffusion is the process by which charged particles flow from a higher concentration region to a lower concentration region. The diffusion junction transistor uses this diffusion technique to form the transistor. In this technique, an N-type substrate is placed in gaseous acceptor impurities and heated. The acceptor impurities diffuses into the N-type substrate to form a P-type layer that is a base on it. Thus, a P-type layer is created on the N-type layer, that is, a base is created on the collector. The entire system is exposed to a gaseous donor impurity and again heated. The donor impurity diffuses into the P-type layer, that is, it diffuses into the base layer to form the N-type, that is the emitter on it. Thus, an N-type layer, that is emitter, is created on the P-type layer, that is, it is created on the base layer. At last, a thin layer of silicon dioxide is grown over the entire surface so that the aluminum contacts can be made for the emitter and the base leads. The next one is the epitaxial junction transistor. The term epitaxial is a Greek word composed of two parts, namely epi, which means on, and taxi, which means ordered arrangement. Thus, epitaxy refers to ordered arrangement on some material. In this technique, a very thin layer of p-type semiconductor or n-type semiconductor is grown on a heavily doped substrate of same material. If the substrate is n-type, a thin n-type semiconductor layer is grown on the substrate. In similar way, if the substrate is a p-type, a thin p-type semiconductor layer is grown on the substrate. This single n-type or p-type semiconductor layer forms the collector on which the base and emitter region may be diffused. The most common epitaxial techniques are ground diffused type, diffused alloy type, and alloy emitter epitaxial type base transistors. So when we move to the next category, the next one is a point contact junction transistor. A point contact junction transistor was first type of transistor ever constructed. It was developed at Bell Laboratories in 1947. The point contact transistor consists of a block of germanium semiconductor with two very closely spaced gold contacts held against it by a spring. A small strip of gold foil is attached over the point of a plastic triangle. The germanium material has an excess of electrons. When the electrical signal passes through the gold foil, it injects holes in the n-type germanium. This creates a thin p-type semiconductor layer over the n-type semiconductor layer. A small current applied to one of the two contacts had an influence on the current flows between the other contacts and base upon which the block of germanium was mounted. A small change in the first contact current causes a greater change in the second contact current. Thus, it acts as an amplifier. The first contact is the emitter and the second contact is the collector. The low current input terminal is the emitter, while the high current output terminal is the base and the collector. So my dear students, in this lecture we had discussed the different construction methods of a semiconductor transistor. So dear students, in the upcoming lecture we will discuss the different transistor configurations. Those configurations may be common emitter configuration, common collector configuration, or common base configuration. So we are going to discuss in detail about these type of configuration in the upcoming set of lectures. So dear students, see you soon. Until then, goodbye, thank you, and all the best.